Hey, yes, here we go. We're going to talk about negative exponents now. Negative exponents, the real question is, what kind of number is it that has a negative exponent? Is it positive or negative? Because it looks like it's a negative number because it has a negative exponent. But be careful, because negative exponents are actually in disguise positive numbers as fractions. Look, watch. Let's take 5 to the negative 5. Well, actually, as you know, from the 1 over principle, this is 1 over 5 to the 5th. Guess what? That's positive. Even take a quicker and easier example. 10 to the negative 2 is 1 over 10 squared, which is equal to 1 over 100. And that's positive. So be careful. What would happen, however, if we had negative 3 to the negative 2? A negative number to a negative exponent. Well, 1 over negative 3 squared. It's equal to 1 over 9. Wow, interesting. But I'm wondering if we had this become a, let's say a cube root or something like that. The question is that positive or negative? 1 to the negative 4 to the third power. Well, what is that? That's 1 over negative 4 times negative 4 is 16 times negative 4, right? That would be negative 4 times negative 4 times negative 4. All of that is going to be equal to 16 times negative 4, and guess what you get? I'm running out of space. I hope you don't mind. I do this. It's equal to 1 over a negative number. So there is an instance at some points where you can get, as we talk, I'm doing this in my head, I think it's negative 88. 4 times 4, 10 is 40, and 4 times 6 is 24. What am I doing? What is this? Okay, there we go. 1 over negative 64. So there are times, in answering to this question, a number raised to a negative number is a negative number. The answer is sometimes. Not often, but sometimes. In this special case situation where we have a odd exponent and a negative base, okay? That's the case. Negative base, odd exponent. So look out for that one, and there you go. Now, 4 times 16, 4 times 10, 4 times 6, yeah, it's 64, right? Yes, it is, thank goodness. All right, now, moving back to this. 6a, 2x to the 4th. The only tricky thing about this is that this exponent is going to be applied to the entire base here, the entire expression in the parentheses. So 2x basically gets written 4 times. So anything that gets the exponent, the definition of an exponent is that it is applied to whatever is inside of those parentheses. And what it tells you is to multiply whatever's in there by itself 4 times. And that's what happens when we do. We go ahead and do 2 times 2 times 2. We do the coefficients and we do the exponent, the variables separately. Birds of a feather flock together. Those 2's, 2 times 2 is 4 times 4 is 4 times 4 is 16, and then x to the 4th, because we add the exponents. These are invisible ones. Add them up, you get 16x to the 4th, and that's the answer to that one. B, this one here, same idea, but now we have to multiply everything in there 3 times, so it's negative 5xy squared. That gets multiplied 3 times, and you might start to ask yourself that this might start to get tedious if this were a big number. And at some point you might want to look for a shortcut. We're going to talk about that later. I want you to practice it this way first because we're going to keep it simple. But when we do this, again, birds of a feather flock together. We are now multiplying powers of the same base. These are all powers. They have the same base, xy, xy, xy. Negative 5s are not, they are the coefficients. So we're going to pull those out because birds of a feather flock together. The negative 5s are coefficients. They're going to flock together. The x's are going to flock together. The y squareds are going to flock together. And some students like to skip this step, and it's not an idea that I would advise. It really is good to write this out. And what's the big deal? It takes another 15 seconds. So now it makes it really easy. You can see that these are invisible ones put together. Negative 5 times negative 5 is 25 times negative 5 is equal to negative 125. And then x to the 3rd, because we're adding exponents. Multiplying powers of the same base, add exponents, multiplying powers of the same base, add these 2's, 2, 4, 6, and there is your answer. Try these over and over again. Now, over here, 7a, it's division. Division, to be like this, when we divide powers, because power is the whole thing, of the same base, okay? Then we subtract exponents. These are the little guys, yeah? Exponents. All right, so moving right along, what do we have here? The coefficient is 4 and 1. I just put in the invisible 1. That's what x is, it's 1x. So we have 4 over 1, that's separate. Then we have x to the 512 minus 502. And guess what we have as an answer? 4x to the 10th, because 512 minus 502 is 10. So that's all you have to do with when you divide. Powers of the same base. This is straightforward. What is it? Multiplying powers of the same base. We add exponents. 6 times 2, birds of a feather flock together. Write it out. Don't take shortcuts. I repeat, do not take shortcuts. Don't do these in your head. Whatever you do not do these in your head. There it is, guys. Let's move right along all the way up here. 8a, 4x to the third. These are really simple repetition of what we were just talking about. I'm just going to move this out of the way now. Now, I am going to start to introduce to you a shortcut. I know this is the way you're learning, and that's good. 4 times 4 times 4, right? X times x times x. These are invisible ones. 16 times 4 is equal to, is it 64? X cubed, right? 16 times 4. And now, there is a bit of a shortcut you could do. I'm going to come back to it. This here, negative 3x squared y, and it gets written down twice. Good, right? And that's going to be 9. Oh, don't forget to write down the coefficients separately. X squared, birds of feathers flock together. 9x to the 4th, y squared, and that's it. Moving right along, similar thing here. We have fractions, this coefficients, negative 2 over 5. And then we have x as the common factor is 216 minus 621. Uh-oh, things are going to get a little complex because now we're going to get a negative exponent. And remember, for these questions, do not leave them as negative exponents. We want to convert them to positives. We're going to keep that negative 2/5. Some people get confused and freak out because they're like, oh no, I can't leave this as being negative. You can. That's a coefficient. So remember, you really have to remember the difference between coefficients, the base, and the exponent. The whole thing is the power, but this is a coefficient. That can be negative. This can't be. So x 216 minus 621. Remember 1 over. Whenever we have a negative exponent, we write 1 over a positive exponent. So it's equal to negative 2/5 and 1 over x to the 405. And I'm talking the same 405 as our beloved freeway here in Los Angeles. And then we can just write this as negative 2 over 5x to the 405. Yeah. Why? Because this is like a fraction. Negative 2 times 1, we multiply the numerators, we multiply the denominators. Negative 2 times 1 is negative 2. 5 times x to the 405 is 5x to the 405. And there it is, done. Over here, our final one. This is now 8D. I'm going to leave some on the packet for you to finish. All straightforward, multiplying powers. This is a power, that's a power. There we go, 7 and 3 we pull out because those are coefficients. Birds of a feather flocking together. And that makes it so much easier. And we just get 21. Everybody knows that's x to the 11th because we add 8 and 3. Y to the 7th, we're done. 7, 11, 21. Looks like somebody likes playing cards or gambling because those numbers are all very famous for a Vegas style gambling show. All right, guys, I hope this helps. Let me know, email me, whatever you need to do. Check your Google Classroom for new updates and also for things that you can learn from in getting ready for the test. Remember, exponents are really only a part of the bigger picture. The big picture is power. Power is the whole enchilada because power is what we call negative 5x to the 10th. This entire thing right there, that's power. And that is a powerful number right there if you think about it. That whole expression. What is this? That's the little guy, that's the exponent, okay? It's kind of like a little bird that sits on a hippo. You know those little birds that sit on hippos? And this right here, coefficient. Please make sure you understand the difference between coefficient, exponents, and power. Power is the entire thing. That's the power. So go get the power. Be good, be cool, do your homework, and get ready for this test. Take it easy, guys. Bye-bye.